Hello and welcome to the Django GraphQL Query Fundamentals course. My name is Xander. This tutorial is part of a whole course playlist available for free on YouTube. For deeper learning, the extended course is available for purchase at Udemy. Now you'll find all the resources and links in the video description. And don't forget to subscribe to the channel for weekly promotions, discounts, and Udemy course giveaways. In this tutorial, we're going to learn how to set up a one-to-many relationship in Django using the foreign key field. What we will also learn when building relationships between tables is that we will need to specify how that data is managed should we delete data from either side of the relationship. A one-to-many relationship is probably one of the most common ways to link models together. Let's take a look at, for example, some of the one-to-many relationships that we have. Now, we haven't worked through the design process of this database. We have been simply presented the final design. If we were to have worked through the database design process, we would at one point had to determine the type of relationship that we might have between individual entities or tables here. So we would have looked at each table and asked ourselves some basic questions. Is the data in the category table related in any way to the product data? If the answer was yes, then potentially we have a relationship. So when we build relationships between tables, we are essentially saying that the data in the product table has a relationship with data in the category table. So here, for example, one product, when we add a product, we want to make sure that that product is associated to a category. Now, the category data just happens to be in a separate table. So we need some way of being able to connect our products that we add to the products table to the category data. And we can do that by using foreign key references. So we think about a record in the category table. We have a primary key, which is a unique identifier for a record. So this is one record. And then the category also has, for example, a name field. So let's just call that TV for now. Okay, so then we have our product table. Now, the product table, remember we have some sort of primary key to uniquely identify a new product that we insert into our table. And the product might have a name, for example. So let's just call this TV R1 TV. Okay, so whatever the name of the TV is. And then we also now include a foreign key. So this foreign key field, what we try and do here to build connections between the product data and the category data is that we can specify the primary key of a corresponding category. And by doing that, it means that we've now essentially connected this product or related this product to this category via this foreign key reference. So if we were to query this product data, we could use this foreign key referenced to then determine what product this category is connected to, or what category this product is connected to. So now we can determine the type of relationship that we have between these tables. Now we've identified how the data is going to be formed and related between products and category. Because what we have here is for one product, it is connected to one category. At least that's our business logic. Potentially, we could set up our product to be connected to multiple categories, but we're not going to do that in our project. So we have a one-to-one relationship. One product is connected to one category. And then we start from the category side. We say one category is connected. Well, we can see it's connected to potentially multiple products because one category can serve as the category for multiple product records. So we have a one-to-many relationship. So if we do the calculation, one and many, that equals many, and 1, 1, that equals 1. That means we have a one-to-many relationship between category and product. If we look at the database design, I think we have another one-to-many relationship between users and orders. So you can tell by the line and the crow's foot and the 1 here, one-to-many. So for one user might be connected to multiple orders, and for one order, each order is connected to only one user. So again, we have a one-to-many relationship between users and orders. So how we set up our one-to-many relationship is that we're going to need to specify a foreign key field in the side of the relationship where the many resides. So remember, in our case, the many is over here in the product. That's what we've determined. So that's where the foreign key needs to reside. So I've now added to my product model a new field called category, and then I've now defined a foreign key. So within the foreign key, I need to define first of all the table that we're building a relationship to, and that's the category table. And then I specify onDelete, which specifies what should happen to the data if we were to delete the parent data, in this case the categories. And then we can also specify a related name. Now we have multiple options for the onDelete. Here we're specifying what should happen to the data when we delete the parent data, which I'll explain shortly, but let's take a look at the options that we have. So we have cascade, which means that we delete the related objects. We have protect, so we can actually prevent deletion from actually happening. And we can also, for example, set null or set a default value, or potentially do nothing. So you can see we've got lots of options here, and we need to determine the best option for our particular scenario. So take this example here. We have a category, primary key 1, and then we also then have our product, which you can see that 2 of our products are connected to this category. So what we're saying here with the onDelete is what happens when we delete this record, because the product data still has a reference to it, but of course now we've just deleted it, so it doesn't exist anymore. So what should happen to this data? Now, because this data is related, the default behavior we can use is cascade. So if we set cascade, it means that if we delete, in this case the category, any other related data in the other table that's related to it, i.e. these records, that will also be deleted. So when we use cascade, it's going to delete the related objects as well. Now you can imagine that isn't necessarily a friendly behavior in all scenarios. Imagine you had 1,000 products connected to a category, you delete that category, well, all those products are going to be deleted as well. So that's not necessarily very desirable. In some cases, that will work well for you, but don't forget you've got now multiple options to choose from. So maybe in that case, you might want to set to a default value. You might have some sort of default category value that you can assign it to, or potentially you want to protect and avoid that. So using protect, for example, means that you cannot delete category in this scenario unless all of these products have been changed from the referencing category. So if we were to delete these products or remove the foreign key from these records, we can then go ahead and delete if we set this to protect. So it's up to you what you decide here. I'm just going to specify cascade, and that might be useful for us to demonstrate certain aspects a little bit later on when we start querying the data. But of course, you just need to be careful to make sure you set this up correctly for your particular database. Right, so you're going to need to specify that for any foreign keys that you create. And then the related name here allows us to access the reverse relationship from the category side. So for example, if you have a category object, you can then get its related products by using this related name. So this is just a nice friendly way of enabling us to actually work with the category data and then get related data instead of, for example, working from the foreign key side and say querying from this side, starting from product. Because if we start from the query from the product side, we already have the information related to the data that we want to relate to. So if we query from this side, it's easy to get the category data. But if we start from the category side, of course, there is no foreign key here. We don't know anything about the related data. So we set up the related name to allow us to access what we describe as the reverse relationship. So the relationship from this side over to product. Now, you don't necessarily need to worry about that for now. As and when we start to delve deeper into the course, we can potentially use these related or relationships to help us query the database. Now, what you might have noticed is that there is a foreign key here in the category, and it's not necessarily related to anything. It doesn't look like it because there's no lines here. So really, there should be a different line coming off here. I forgot to add this in actual fact. So what we can do is add a relationship like this, because this is a self-referring foreign key. It means that we can create a hierarchical setup within this particular table. So what we have now is the capabilities of, for example, adding a, let's get the pen back. So we have the capabilities now of adding a foreign key here. So let's imagine we needed some subcategories for TV. So let's just go for a Sony TV. So let's imagine we wanted to connect this category to the TV category to make some sort of hierarchical data. So what we can now do with this self-referring foreign key is reference the primary key of the category that we want to build a relationship to. And that way we can, in this single table, build a hierarchical set of data, because we can have one category connected to another. We can then potentially connect that category to another or to multiple categories. So we can really start to build this hierarchical set of data within the category table. So this is what it's going to look like within our model. We have the name of the field, and then it's going to be a foreign key. We define self. So this is a self-referring foreign key. So self just refers to this class. So that's going to set up a foreign key to another category in this case. And I've set the onDelete to restrict here, which means that we cannot delete the parent record category unless any other associated categories have been removed first. Let's also not to forget that the order table, as we saw in the diagram, also requires a foreign key. So I've quickly set up all the fields for the order table. So this is the complete order table. So I've set here the foreign key to user, onDelete cascade, and I've also set up the created at and updated field. We'll take a look at the DunderString methods a little bit later when we discuss how to register this model in the admin panel. So we've now seen how to create a foreign key field and how to set up a one-to-many relationship. We've also seen the different types of onDelete options and what they do. That's going to be really important for understanding how our data is going to behave when we start to perform actions such as deleting data from our database.